Here we have a ramp with a cart on it. This cart is in equilibrium. It has a string attached to the front with a tension T. So this is the force acting on the cart. The cart's not moving upwards at all, it just has enough force so that it's staying still. There's also mg, which is the force acting downwards to the earth, which is mass times gravity. The third force is often forgotten. It's called normal force. It acts on every single person and object, and it keeps it from falling through the floor. It keeps it on the ground it's on. And F norm is always going to be perfectly perpendicular to the ramp or whatever surface it's on, which is unlike mg, which just always points down towards the earth. To find these values, we're going to draw an x and y plane. The normal force and the t is easy to find because they are with like the x and y. But mg, this is where mg would be. But we want to find here and here. So this right here is going to be mg cosine theta. And this is going to be mg sine theta. To remember that sine is here and cosine is here, I just think that sine and slides, because right here is the ramp, so it's going to be like on this axis. For this cart to be in equilibrium, F norm and mg cosine theta have to equal each other. Mg sine theta and t have to equal each other. So we're going to focus on just these two today. There you go. So F norm equals mg cosine theta. To solve this, we need some actual numbers. So we're going to say that this angle right here for this ramp is going to be 22 degrees. The mg, so the mass times the gravity, is going to equal 2.5 newtons. So we're just going to solve this like normal. This is going to be 2.5 times cosine theta, which is 22. When you solve this, you're going to get 2.3 newtons. So that means this value right here is going to be 2.3. This mg is going to be negative 2.3, so they cancel out. What you should take away from this is that if your cart has two x forces that cancel out and two y forces that cancel out, even if that y force is from the ramp or from a string, that cart will be in equilibrium. It doesn't even matter if the ramp is there. It will still be in equilibrium.